Hello, my name is Katerina, and today I'll be presenting our recent work on the evaluation of language models through text without gendered language. I'd like to begin by considering the set of all English sentences that involve either male or female pronouns. Prior work has focused on a subset of these sentences, proposing numerous benchmarks that target undesirable harms and stereotypes like those related to occupations. And while these benchmarks have enabled remarkable progress in terms of identifying and mitigating gender biases within current state-of-the-art models, model behavior remains largely unknown in this larger subset of English sentences. And considering the widespread deployment of these models in diverse open-ended generation tasks like summarization or assistive writing, it is crucial to fully understand and characterize model behavior in these different scenarios and test their capabilities so to ensure that they are not propagating biases that are unintended. In this work, we investigate this overlooked aspect of gender bias evaluation and assess model behavior using non-stereotypical sentences. But before we can actually do so, we first need to define what non-stereotypical sentences are. In our context, a non-stereotypical sentence is a fluent English sentence that is correct under both genders and whose words are minimally correlated with gender according to the pre-training data. This last property contrasts with a commonly held observation in prior work that models reinforce stereotypes as a consequence of gender correlations present in the training data. Once we gather a set of sentences that satisfy all these properties, we can now think of how to use them for evaluation purposes. In particular, we start by decomposing this template into its gendered versions by replacing placeholders with the corresponding gender pronouns. Then we feed each of these sentences individually to a language model to compute their likelihood. By comparing their likelihood, we can then observe whether one of them has an unproportionately higher likelihood than the other, and if so, we say that the language model is unfair for this sentence pair. By repeating this process to all the examples in the evaluation set, we get our fairness metric. But how exactly can we get these non-stereotypical sentences to begin with, right? One option is to use existing gender-neutral datasets like we know bias or we know gender and filter out sentences that have strong gender correlations. However, do note that because these datasets are stereotypical in nature, doing so tends to result in smaller datasets, potentially weakening the validity of bias assessments. To strengthen our analysis, therefore, we also include in our evaluation newly created benchmarks that are devoid of stereotypes altogether. In particular, we leverage language models to create natural-sounding non-stereotypical datasets from scratch, using diverse set of seed words and gendered pronouns to ensure higher diversity and effectiveness in this generation process. Put it in other words, we select seed words from a vocabulary based on their co-occurrence with the gender pronouns he and she, where these co-occurrences are computed based on PILE, a large pre-training dataset used to train popular language models. Then we feed these seed words and gender pronouns to ChatGPT and ask it to generate sentences that contain both words. For every generated sentence, we generate its minimally distant gender pair and filter out pairs whose resulting sentences are unnatural or unlikely to occur in practice. Finally, we remove sentences containing words that are known to be correlated with gender in the pre-training data. This proposed pipeline can be executed iteratively and as many times as you'd like to generate a diverse, large-scale set of sentences that are both gender-neutral and stereotype-free. Please check the paper for more details or feel free to send us an email. Using the ideas that we discussed before, we now tested 28 popular language models across 5 non-stereotypical datasets. In particular, we hypothesized that since we're removing sentences correlated with gender from these evaluation sets, models would assign roughly the same probability to both gendered sentences. To test this hypothesis, we compute the percentage of examples for which models exhibit no gender preference. If our intuition is correct, then we would expect models to achieve a score closer to 100. However, this is not what we find in practice, as all evaluated models tend to be overconfident and assign more probability mass to one gender sentence over the other. This is also verified across all 28 language models and benchmarks, and we invite you to check out the paper for more results and interesting findings. To conclude, this work challenges pre-existing observations in fairness evaluation of language models, introducing a new framework tailored for diagnosing model behavior in non-stereotypical scenarios. It also evaluates popular language models like Llama 2 and Mistral, finding all models to be biased despite the absence of stereotypes. Thirdly, it exposes previously overlooked language model behavior and raises important questions about where these underlying model biases come from, highlighting the need for more systematic and comprehensive bias evaluation. I'll wrap up our presentation by encouraging you to check out our paper for more details and results. Thank you, and hope to see you in Vienna.